All right, guys, we're gonna just jump into kind of a mini project that we're gonna do, and it's our reverse engineering mini project. It's gonna take the next 4 weeks, this week and then 3 more weeks, and it's basically gonna be a really fun project, I think, for us to do at home. That we can just explore the process of reverse engineering and taking something apart. I think it'll be really fun. So let's get into it. So, what is reverse engineering? It's the process of taking something apart and sometimes even putting it back together. So, a lot of knockoff products were developed through reverse engineering, right? You go to the store and you have Cheerios, and beneath Cheerios, there might be some weird other O's um, that look like Cheerios. You might even read the ingredients, and they have the exact same ingredients as Cheerios, but they're not quite Cheerios. Um, and honestly, a lot of times you close your eyes, you do like a blind taste test, they might even taste the exact same. But because of the labeling and you thinking that Cheerios are better, in reality, when you know Cheerios taste better and the other ones don't taste good at all. Um, Same thing with like knockoff iPhones, right? But knockoff iPhones probably we know aren't as good of quality. They might not be using the same materials. They definitely don't have the same software. Or knockoff Beats, right? Like students have gone to China, they bring back knockoff Beats. Um, so that's one reason, right? But really, the main reasons that people undertake this process of reverse engineering are to understand a product better, um, to see inside of it, just to kind of figure out how does it work, to examine the structure of it, how it was built, the function of it, like what it does and why it does it, how it operates, maybe to duplicate it, right? To remake it or to improve it, right? You might reverse engineer something that your own company made because they want to reduce the cost. They want to make it cheaper. They want to improve the materials and make it stronger, better. They might want to reduce the environmental impact. A lot of water bottle companies do this all the time. They are trying to use less plastic because plastic is bad for the environment. They have to use plastic because that's how water bottles are made, but they're trying to figure out how do we use less of it, right? Sometimes companies might actually completely change the material to help the environment. Um, Maybe to also increase the efficiency, right? Make it work smoother or make it more reliable. Maybe to even add on features, right? Like in second version, right, of a product, right? There's always like the iPhone, then the iPhone 2, the iPhone 3, the iPhone 4, making it better and better. So by reverse engineering it, taking apart, you can work on making it better. Okay. Um, so our first step for this project is going to be a project proposal. And the first thing is going to be to figure out what it is that we want to take apart. So you're going to find something in your house and that you want to take apart. You're going to write a description, the cost, and the source. The cost, you're just going to Google how much did this cost originally, right? It's you shouldn't be going to the store. I want you getting something from home. The source hopefully should be your home, right? We're in quarantine. What does the device do? So what is its purpose? How are you going to take it apart? What tools do you need? You might need a screwdriver. You might need a wrench. You might be able to just do it with your hands, right? Then how many parts do you think it contains? At this point, it's a guess. I think it contains 6 parts. I think it contains 5 parts. I think it contains 10 parts. And what do you think you might find inside? If you're doing say a pencil, like a mechanical pencil, you might expect to find lead inside. You might expect to find a spring inside, right? What do you think is going to be inside? And then a rough sketch of the overall device. Rough sketch meaning it doesn't have to be a good sketch. It doesn't have to be totally to scale. Just sketch it out like a 2-minute sketch. Think of it that way. Like, please don't spend 30 minutes on your sketch. It should be like a 2-minute sketch. Okay, this should be ideally due tomorrow, but if you watch this video, I'm going to actually give you guys until Sunday to turn this in. So if you can do it by tomorrow, great, but if not, by Sunday, I won't mark you late. All right, tools, right, just some things you might need. Most of you guys aren't going to need, like, really, most of you guys are just going to need a screwdriver. You might not even need anything. But most of you guys will not need a drill, especially a power drill like this. If you are going to use something like this, I wanted to caution you guys, please have one of your parents with you. Don't use this on your own. So ideally, we just need a screwdriver, maybe a wrench. If you have a caliper, great, that's awesome. If not, hopefully you have a ruler. If you took your engineering notebook home, it has a ruler on the side. If you absolutely don't have a ruler, just use something for reference. Usually like the knuckles between your fingers is about 1 inch, and you can just kind of guess at it. All right. We're going to be doing a bill of materials. I'll go through this later, but basically we're just going to write down each different part and then how many there were. So if I was taking apart, say like an old Bluetooth speaker that I have, maybe there was a screw, but there were like 4 screws. I'm just going to write it once, just screw. And then the quantity is 4. The dimension I might just guess at. The function is to hold things together. What did it interact with? Like it connected to the base of the speaker and the insides. You can skip research cost and website. If there was a second screw but it was longer, then yeah, you can have short screw and long screw. Maybe you have the buttons, right? There were like 3 buttons. Maybe I have the case. There was a case. Maybe the actual speakers themselves, right? For dimensions, if you have a caliper, you have a ruler, use it. If not, just do your best estimate, okay? You're not going to have to do this week anyways, so we'll talk about that more later. Your overall report requirements, you're going to make a small report. You write the purpose of the object. You're going to have that bill of materials. You write the procedure. How does this object work? How did you put it together? You have your sketches and a short little conclusion. What happened? What might you have done differently? And then 3 possible changes that you can make to make this product better. All right. For sketches, again, this is going to be next week, or actually in 2 weeks, but we're going to be able to do sketching by hand or using Onshape. For sketches, if you're doing them by hand, I want them probably top view, right view, that's orthogonally, and maybe an overall one isometrically, right from the side view. Using Onshape, it'll be a little bit easier. If you're using Onshape, I'll post a video of another teacher who's kind of done something similar with this. They don't have to be perfect in Onshape, just kind of make it look like your object, have roughly similar dimensions. And then for an exploded view, you can either sketch it. This is a sketch of an army knife from like a 1986 Army magazine. But you can sketch it like this, or what I would actually do and what I'm fine with is just take a picture of it, right? And kind of lay it out, on a table, how it would connect back together, and just take a picture, okay? For your object, this is what we're going to be doing like today, tomorrow, is we're picking out our object. So you're going to pick an object, and I want you to pick something that has at least 5 different unique parts. Like I said before, if you have a screw, even if there are 4 screws, it only counts as 1 unique part. Now, if you have a long screw and a short screw, that's 2 parts. But if they're all the same size screw, that's just 1 part. Okay, I want a low voltage device. What I mean by that is nothing that plugs into a wall. You should not have to have a power cord for this. I don't want you to pick that object. Pick something different. If it takes a battery, I'm okay with that. But I definitely don't want anything that plugs into the wall. The wiring there, it gets too messy. Okay? And then I want unwanted items. The reason I say that is your object will probably not work after we do this project. So things that you can throw away. Hopefully it was under $5, but if you're going to throw it away anyways, fine. Okay. So some ideas, things I've had people do in the past. Someone brought in like a toy model rocket thing. People have done Nerf guns. One person brought in an old fishing line or fishing, we just did this, this part of it. I forget exactly what this is called. The reel, I think. But you take this apart, you take apart the rod, if you have something like that. Basically, things that you might find in your garage that are trash. Ask your parents, make sure, hey, can I take this apart? Like, can I break it? Right? People have done old wagons and tricycles, but make sure, like, if you have a younger 3-year-old brother and it's his tricycle, don't take apart his tricycle and possibly break it, right? If you have an old tricycle or an old wagon that no one's used in years, then you can probably use that. But again, just ask your parents that it's okay. Staplers are good. Tape dispensers are good. But again, make sure your parents know, hey, I might break the stapler. Is it okay? Old kids' toys are okay if you have any old kids' toys. These are usually really, really fun and don't have a whole lot of complicated parts. They're mostly plastic. This would be a big recommendation. If you have any old kids' toys kind of looking like this little telephone guy, that's a great one. And the other great one, and my big recommendation, especially if you don't have any tools, is mechanical pencil or pen, right? You don't really need any tools to do a mechanical pencil or pen. Most of you guys, honestly, if you ask your parents, you probably do have a screwdriver somewhere. So most of this stuff, if you have a screwdriver, it's easy enough to take apart. But if you're like, I have nothing, or I just want to be a little bit simpler, right? A very simple one is a mechanical pencil or a pen. They work well and don't need really any tools. Okay, I'm going to repeat this one more time. Don't do anything that plugs in, right? Anything with a lot of electronics that plugs into a wall, don't do. Don't do anything that you want to keep. Your project will probably not work. Some of yours might work afterwards, but expect that it won't work. So anything that you want to have working that you want to keep, don't do. And then any item with too many parts, right? Taking apart like an adult bicycle, every single part is going to just take you way too long. So think about when you're picking your object, hey, this is something I need to take all of it apart, and I might need to sketch some of it, so be aware. All right, kind of 4-week schedule. This week we're watching the video, we're brainstorming, we're writing our proposal. I'm going to post that proposal tomorrow as a document. Right, the proposal was these questions here. So these questions here I'll post as a document. It's technically due tomorrow, but I'll accept it up to Sunday. All right. Then week 2, next week, you're going to be taking apart your device, taking a couple pictures to document that, and answering a couple questions. Week 3, you're going to sketch your parts and do that bill of materials. And week 4, you're going to put it all together in a report, write a couple conclusion questions. The report's not like long, it's just literally just having everything together. And then really that's it. Optional extra credit. If you want to create a video, either making a PowerPoint and filming your screen, or some kind of screen recorder, or even having a family member, right? You just hold up what you did, like you have your object taken apart and you hold it up and kind of talk about it. It can be a short video, but you're just making a short video about what you did and sharing that with the class. Either post it to YouTube or the Google Drive and share it. I will give you guys extra credit for that. I will post some of these rubrics as we get closer, like the written report rubric, and the oral presentation would be if you did the video. And then just kind of reiterating, this is part of that design process. So it really fits into this improving, testing and evaluating a lot, those steps, but really we'll be doing all of these steps when we do reverse engineering. So I think this should be a really fun project. Pick something that you are excited about, that you're wanting to take apart, that'll be fun for you to do. If you have any questions, please ask me. If you don't have any tools, that's okay. Just pick something that you can take apart by hand. Right, like a pencil box might work. Definitely mechanical pencil works. You guys look around your house where you live. There should be a lot of things that you can take apart easily. But if you do have a screwdriver, then it opens up some more possibilities. Like I said, kids' toys, if you have any old kids' toys, are really fun to do. So let me know if you guys have any questions. Please make sure that if you can turn this in tomorrow, Wednesday, that's great. If not, definitely by Sunday. If you have any questions, email me and I'll get back to you. Thanks, guys, and I'll be talking to you soon.